A rocket is launched at an angle of 53 degree to the horizontal with an initial speed of 100 meter per second. It moves along the initial line of motion with an acceleration of 30 meter per second for 3 seconds. At that time, the engine fails and the rocket proceeds to have a free fall. We have to find out various factors over here. If I say that this is the x-axis, this is the x-axis, and this is the y-axis, this is the horizontal and the vertical axis. Initially, the rocket performs a straight motion, okay, a motion along a straight line, okay, where the initial point let it be equal to 0 until the point it performs the motion along a straight line, let the point be equal to a. It makes an angle 53 degree with the horizontal, okay, it makes an angle 53 degree with the horizontal. After that part, the rocket performs a projectile motion and it returns to the ground, okay. So basically I will divide the sum into two parts, from point O to A and from point A to B, okay. Now the initial part over here, from O to A, the particle is traveling along a straight line with an acceleration of 30 meter per second 30 meter per second square. The initial speed is given as 100. So we will use the formula V is equal to U plus AT, okay. Now initial speed is given as 100. Therefore the acceleration will be equal to 30 and time is given as 3. So basically it will be equal to 190 meter per second, okay. The velocity at point A, let me say that at point A it will be equal to 190 meter per second, okay. Now the velocity will make a certain angle, okay. The initial velocity will have the same angle as that was obtained, that is 53 degree, okay. Now let us see the vertical and the horizontal heights. Let us first find out the total displacement. S is equal to ut plus half at square, okay. S is equal to ut plus half at square. Now the initial velocity is equal to 100. The time period will be equal to 3 seconds plus half a t square, okay. The half a t square, the acceleration is given as 30 into 3 square, okay. Acceleration is given as 30 into 3 square, which will be equal to 300 plus 15 into 9, okay. 300 plus 15 into 9, which is equal to 135. So basically it will be equal to 435 meter, okay. The total displacement is equal to 435 meter. I can say that if this is the horizontal range R1 and this is the horizontal range R2, the height covered over here will be equal to h. So basically h will be equal to s sine 53 degree and R1 will be equal to s cos 53 degree, okay. So s sine 53 will be equal to 435 into sine 53 will be equal to 3 by 5 and it will be equal to 435 into cos 53 will be equal to, the sine 53 will be equal to 4 by 5 and cos 53 will be equal to 3 by 5. So basically it is equal to 4 by 5 and this part will be equal to 435 into 3 by 5, okay. This will be the total h and the R1. So basically it will be equal to 86 into 4, okay, 86 into 4, which will be equal to over here 86 into 4, which will be equal to 344. The total the total height at which the engine fails will be equal to 344 and over here 86 into 3, okay, 86 into 3 will be equal to 258 meter, okay. Now I have the horizontal range R1 and the vertical height from which the projectile is launched. Now over here if you see, the velocity also makes an angle 53 degree. Now let us see the, if I calculate the velocity over here, what was the velocity? It was equal to 190 meter per second, okay. It was equal to 190 meter per second. So in the horizontal direction it will be equal to 190 into cos 53. Cos 53 will be equal to 3 by 5 and in the vertical direction it will be equal to 190 sine 53, which will be equal to 190 into 4 by 5, okay. In the horizontal direction is equal to 190 into 3 by 5. In the vertical direction it will be equal to 190 into 4 by 5, okay. So we have to calculate the total velocities and the total time it takes to land on the ground. Now initial velocity in the vertical direction, now let me take the section from A to B, okay. Let me take the section from A to B. Let us calculate the time taken, okay. Let us calculate the time taken. Now over here I can say that when the body is launched with the initial velocity of 190 into 4 by 5 initial velocity, what is the maximum height? This is the maximum height. Okay, let this be h1, let the height over here be h2. At the maximum height, the vertical velocity will be equal to 0. So v is equal to 0. Initial velocity over here is equal to will be equal to 190 into 4 by 5, which is equal to 38 into 4. Okay, which is equal to 38 into 4, which will be equal to 152 meter per second. Okay, 152 meter per second. Okay, now the final velocity is equal to 0. Let us calculate the height. It reaches. Okay, so h2 will be equal to, we can use the formula v square is equal to u square plus 2as. Okay, v square is equal to u square plus 2as, which is equal to 0 square is equal to 152 the whole square. Okay, minus 2 into 10 into h2. So basically 20 into h2 will be equal to 152 into 152. Okay, so basically 20 h2 will be equal to 152 into 152. Now over here, understand that h2 is the height above the height h1. Okay, h2 is the height above the height h1. So if I want to calculate the total height, it will be equal to h1 plus h2. So basically h2 first of all h2 will be equal to 152 into 152 divided by 20. Okay, so it will be equal to 1152, roughly it will be equal to 1155, okay, meter. Okay, so the total height reached will be equal to h1 plus h2. Now h1 is given as, h1 I have already found out, it is equal to 344. So 344 plus 155, okay, or 1155 will be equal to 1, it will be equal to 99 into 1499, roughly it will be equal to 1499 meter or 1.5 kilometer. Okay, 1.5 kilometer, this is the maximum height reached. Okay, I have calculated the maximum height. Okay, I have calculated the maximum height reached by the rocket. Let us calculate the range R2. In the horizontal direction, let us first find out the time period. For the projectile to return to the ground. Okay, now over here, the initial velocity, the horizontal height is h1, which it has to trace in the vertically downward direction. So I can say that when the projectile is launched from this height and it reaches the ground, its displacement will be equal to negative h1. Okay, its displacement will be equal to negative h1. So the displacement over here is equal to negative 344. Initial velocity in the vertical direction will be equal to, it is equal to 190 into 4 by 5. Okay, 190 into 4 by 5, that is 38 into 4. So the initial velocity I have already calculated, which is equal to 152. Okay, so we will use the formula S is equal to ut plus half at square. Okay, now the S over here is equal to minus 344. Initial velocity over here will be equal to 152 in the vertically upward direction into t minus half into 10 into t square. Okay, so if you see, this is a very lengthy equation. Okay, we have to find out the total time period. Okay, now the time period I have divided into two parts. The first part is to go from point O to A. Okay, and the second part is to go from A to B. Okay, so if I solve this simultaneously, it will be minus 344 is equal to 152 into t minus 5t square. So 5t square minus 152 t minus 344 will be equal to 0. Okay, will be equal to 0. So now over here, if I calculate the value, the time period will roughly come out to be 33 seconds. Okay, the time period will roughly come out to be 33 seconds. Now the total time period is again over here. Let this be time t2. The first time period to go from O to A, which is given as the first time period to go from O to A, which is given as 3 seconds. It is followed by 33 seconds. So T1 plus T2 will be equal to 3 plus 33, which will roughly be equal to 36 seconds. Okay, which will roughly be equal to 36 seconds. So I have got the total time period too. Okay, the last thing I want to calculate is the horizontal range. For the horizontal range, the velocity over here will be equal to 190 into 3.5. The initial velocity over here, is over here is equal to 190 into 3 by 5. Okay, 190 into 3 by 5, which will be equal to 190 into 3 by 5, which will be equal to, if I calculate this value, it will be equal to 190 into 3 by 5 will be equal to 38 into 3, okay, which will be equal to 38 into 3, which will be equal to 114. Okay, the initial velocity along the horizontal direction is equal to 114 meter per second. Okay, now if I want to calculate the total R2, the time period is given as 114 into time period over here is equal to 33 seconds. Okay, 114 into time period over here is given as 33 seconds. So basically it will be a simple multiplication of 114 into 33. Okay, 33 I have taken an approximate value. Okay, if you calculate the approximate value, it will come out to be 33. So R2 will come out to be 3762. Okay, R2 will come out to be roughly, it will be equal to 3762 meter. So the total range over here will be equal to R1 plus R2. Okay, total range over here will be equal to R1 plus R2. Let us see the value of R1. It is equal to 258 meter. Okay, it is equal to 258 meter. So 258 plus 3762. Okay, so 258 plus 3762 will roughly come out to be 4020 meter or 4.2 kilometer. This will be the range. So I have got the range 2, which is option, which is the third sub question also. I have found out the answer.